Question 13 was a long question, and it was really about, I suppose, validation checks, testing, and logic gates, a sort of combination of those things. They started off by giving you an error code and told you the rules of the game. You gotta have letter, digit, and then 4 things that could be alpha, alphabet, numeric, and then they gave you this one as part 1. They said, why is this not okay? And you had to spot that the second guy there was not a digit. The next one, you had to say that the rules say 3 characters and then 4, and not like 4 characters and then 3. So that was what was wrong with the second one. And then the next one, they weren't even trying. Like everything was wrong with it. The first one, 8 is not a letter, X is not a digit, and T is not a digit. So there you go. That was what you had to say for those ones. And that was a real nice start to it. It's, can you work in error code? So they give you this big chunk of code, which if you're reading top down, it can actually get a little bit confusing with the if not return false. There's a lot of like double negatives back and forth. The best way to approach things like this is actually not read top down. Look inside the brackets and work outwards. It's like that Titanic dinner where you have to start on the outer. Is it the outer cutlery and work inwards? Anyway, that's the total opposite of what I said, if that's the case. This 0 in square brackets. Start there. What does 0 mean? It means the first term. If someone says to you in Python, you are my number 0, they mean you're the number 1, That's just how we count. 0 is the first term and 1 is the second term. So it's saying, hey, 0 in the test error code is an alpha. That makes sense, right? Look at this. 0, so the first term, the letter there, for this guy G, is it an alphabet? Yeah, it is. That's fine. Yeah. So that's what that does in the code. Don't worry about the if not return false. Just know, like, that's probably just checking that bit. That's what it's doing. All right. Let's go down here onto line 16 and look what these things here are doing. Well, 1, which we now know from counting, is the second digit, and 2 in Python list is a third digit. Okay, because you can count here. You can see there on the right, I've done a little diagram to remind you. So second and third digit. Oh yeah, 2 and 3. They are digits. That's what it's checking there. Okay, so this little bit of code is saying this and that, and what's in between them? Or. So if either or of them are a digit, return false. Actually, was as return, usually return true. Oh no, yeah, we'll get on to that. But you can see what it's doing. It's looking at those 2 digits, and that's all you need to understand for right now. And lastly, the last bit, -4. What's it checking? Sure, isn't it not checking the last 4 digits are up to something, So that's it. That's what the kind of code does, and we'll figure out all the ifs and the nots later on. And we're doing validation checks. So it's going to ask, what is a validation check? And what you got to say is, it's a check that makes sure the data is sensible and reasonable and appropriate. It doesn't actually check if it's right. It just checks that you didn't put in a picture of an elephant where it was expecting an email address, and it's just important to mention that it's not like the accuracy. And it comes from the French validus, which means strength. So there you go. And Prince Valiant, a classy 80s cartoon, which has really nothing to do with this question, but I wanted to put it in there because it was Game of Thrones on the den. So there's the marking scheme. It's saying a validation check is carried out by a program to make sure that the data is in the correct format. Yeah, correct format. Could be like it's checking there's a .com and a website, or a .ie or a .something, and probably not emojis, in the context of an error code, a validation check will make sure it conforms. Now look, they're really a bit of a mouthful there. Conforms to the rules of the routing key and the unique identifier provided at the start of the question. I don't know how many people actually would ever say that, but luckily for everybody involved, it says good explanation, 2 marks. So I think that first bit of the marking scheme was quite reasonable. You know, a program that makes sure the data is the correct format. The second bit, outline briefly how a test could be used to test the code above. Well, I would do this like you're explaining it to your granny. When you're explaining anything like this, you could really end up with a giant paragraph, and then if you're not accurate with your speech and your terms, you're describing it, you could go an awful rant and say nothing at all. You would end up like talking like a politician. You know, you talk for hours, you don't actually say anything. So now actually in this case, the granny here is I think Margaret Hamilton, who wrote the Apollo code there. There it is. That's a lot of code. So if your granny is not Margaret Hamilton, though, and imagine you're describing this error code checker over the phone. That's how you want to be answering this question. So step 1, you know, what would you do here? How would you make a test case? Well, you put in a test code, a test error code. You might say, well, I know my own error code, right? So I'm going to put that in. Or I know what's not an error code is this. I'm just like mash the keyboard. I put that in, and see that should give a false. That's the first logical thing that anyone would do, right? So I put in a little. I got this. If you want to play around with this program, by the way, I popped it here on REPL for you, so you can open this up, and you can play it here. And I've put in a test case in Python down the bottom, just to kind of show you. So this is the code they give you in the exam. And down here, I've put in test case equals 1, 2, 3, 4, 5, 6, 7, 8. If valid, this, else that, you know? So that's how that works, and you can play around with it. And then, but really, you don't have to like write Python. You just have to describe it in English. So in short, what this program does is, if it's a valid error code, it goes true. If it's not, it goes false. But it's all just one function, right? So you've got to call a function. Nowhere in this code does it actually call it. So if you actually ran this as is, nothing would happen. You have to call the function. And that's what I did later on with my test case down here. I call this function above. So now I'm using words that are like initialize, call, arguments, you know, things like parameter, return. They're technical terms. If I was explaining this to a goat, I probably wouldn't use those terms. But, you know, this is one of these cases where it's really good to use these technical terms to be concise, to be accurate, and to be the point. And so your pen isn't moving a lot on the page, and you just get the marks and don't have to like go on a rant, you know? Technical terms have a place when they are needed. Here's the time for it. It's like on a boat. If someone says pull the rope, and there's 29 ropes, you need to say, you know, pull the main sheet, pull the jib sheet, get the guy rope. You know, that's why we have these technical terms. And this is, in this case, one of these cases where I'm going to say initialize a test case is way better than saying down here, right, so make a string and make it something like 1, 2, blah, 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 and then put that equal to, and you're like, oh no, scrub that, assign that to a variable, for example, test case. That's so much writing and so much talking. You could have just said, initialize a test case. Initialize a test case string. There you go. Call the function above. So all this thing they gave you was a function. Call it. With the above test case as an argument. I'm going to explain what I mean by this in a second. If the function returns true, the error code is valid. If false, it's not valid. All right. So I was trying to be concise there. Now, what do I mean by argument and calling and returning and all that kind of stuff? Okay. This is your definition up here, and you're calling it down there. You've seen this before where, you know, def message, this kind of emojicon here, and you call it with the little brackets. And when you call something, you make these kind of like call hands, like, oh, function, like this. You call your function because your function is way up the top of your program, and it can't hear you from up there. So you need to put your two hands like this and go, "Whoa," and call it. And that's how programming works. When you define it, you make a little kind of Muppet face here after your brackets. So you define a function, it's bracket, bracket, colon. But when you call it, you use your two hands like this to make sure the sound travels. There you go. Again, there's your definition and your function call and your output down there at the bottom. And you can see here, look, here I've got some parameters at the top. So instead of just bracket, bracket, when I would define it, I've got two inputs there, two holes in the function box where I can put stuff, if that makes sense. And the things I put in those holes are called arguments. So here's an example. Now, my question here is, why does the top not match the bottom? I've purposely made these pictures not line up exactly. So you can see the function definition here on the right, where I've got 3 parameters: quantity, item, and price. Yeah. And the arguments I'm putting into those parameters are 6 bananas and 1.74. The guy down there, that diagram wouldn't match up with this, because really where the apples are going in, there should be 3 separate holes to represent each parameter. Well, maybe you can't see it, it's behind the box. But and then what gets returned from the function comes out of that last little kind of a hole there, So this was the test case, and I then call this here is valid test code. See, I'm calling it with the bracket, and the argument I'm putting in there is the test case I'm putting in. Now I could have just typed in 1, 2, 3, 4, 5, 6, instead of initializing it, but that works. So that was a lot of talking to explain what calls and functions and parameters and stuff are, but you know what? It'll really help you to be able to use those terms to keep your answers short. So a test case would be any value passed into the function. That's what I did. A test case, oh look, there's the one I did, almost like I read the marking scheme for it. It would pass through the function, and the result would be compared to the expected result. Yeah, and then that's fair enough. If the error code is valid, and that's what I said, the thing would be true, false otherwise. All right. Next bit. 2 types of testing that could be performed on the code are unit testing and system testing. Distinguish between these types of testing. Well, unit tests are things you do on little components of your code. In this example, that looks like a fine chimney. I'm sure it's well tested, and the propeller looks good. Now, the entire ship is sinking, but we'll wait until the system test to figure that out. So a unit test is something you might do. Sometimes they call it like a function test, it's a kind of unit test where you're just looking at one function. So let's say if you have a feature that is just like, I add sound, I test the sound works. I mean, the thing itself might fail in the system test later on when I bring into the school and get real people to use it. But that's a different thing, What's wrong with this? Switches look great, and the bar looks great. But together, in an integration test or further on a system test, it would fail. Function and unit tests are white box, meaning they're done by you, the programmer. You made the program. You know how to test it. You know how to put things in, what you could change with the code. That's you testing stuff. System tests tend to be when you hand the whole system done in on site or in the school where you're testing it. You get someone else to test it, either a full-time tester or you have your Microsoft, the customer. Or actually a lot of companies these days, they'll just put it out, the early adopters. And black box, meaning the early adopters definitely have no idea how your code works, but they are testing it nonetheless. So there is a kind of like the order to these kind of things. So down the bottom, I've put a little test dummy there. So that's when you're just testing little components or functions or units. So then you put it together, and then the system level tests, this is where you put your test pilot in, and then later on, when your customer completely accepts it and has been using it, they're like, yes, it's super tested. So, and they tend to be black box, meaning your customer and even the test pilot, to be honest, has no idea how your code works. it's so that's it. Well, what's the marking scheme here say? It says unit testing, countermeasure per programmer, purpose is for specific lines of code. Yes. Test cases trigger all execution paths in the code, so you're testing all the things. Typically automated, like you can get like Travis and stuff like that on GitHub to do a quick tests when you change something. It'll make sure that you didn't do something completely bonkers. Form of white box testing, as we said, you made it, you probably know how it works. That's white box. Whereas system testing, it's carried out by maybe QA, quality assurance, like testers. Their goal might actually be to break it, how the system operates under abnormal conditions, like a power cut, that would be something that you didn't think of as a programmer, but real world will let you know. Who was it? George Washington or Napoleon said no plan survives contact with the enemy. I don't know. Typically carried out by testers, as we said, and a black box as opposed to white box, which means your testers have no idea how it works. That's your problem. But there you go. Python will show that A99 spam A10K is totally valid. And that actually makes sense, doesn't it? Because if you look what the code does, the code checks the first letter, it checks then the next two, this or that, and it checks the last four. But if I was to put in the complete works of Shakespeare after T, followed by the script to Harry Potter in full, I mean, it's fine. This works, and the last four work. It doesn't count up how many characters are there. So whether there is like 7 or 7 million, it's going to say valid error code. So the marking scheme says, function only looks at the first 3 characters, last 4 characters. Doesn't check the length. That might have been a good thing to put into this function. Part 5. After the code has changed, why is it important to conduct regression testing? Why is this important? And what is regression testing? It's when you fix one bug, like this little guy here, and he chucks it out the door, and unbeknownst to him, 3 more bugs come in the door, but he thinks he solved the problem. And that happens a lot when you add a feature and you break the last 2 features, but you just test your latest feature. You haven't tested, have you broken the last 2? So this is kind of a diagram to understand it. So F1, feature 1, let's say I have a program that when the internet slows down, it has like a little alarm. Great. Beep beep goes off. Class. I test that it works. Then I add feature 2, F2. I add a little picture that like has a frowny face. It seems to work fine, but the problem is just whatever way I put it in, it actually broke the sound. Now, to do that, I would have to test the sound. But surely we already test the sound. Yes. But regression testing means you have to check the previous features when you add a new feature. So you can see feature 3 here. So maybe I've got like a volume severity. So the slower the internet, the louder the warning thing. So that like uppy downy on the volume might break feature 2 and feature 1. So I have to go back and check all of them. Every time I add a new feature, I have to check all previous features. So that is regression testing. It's kind of like paranoid. Like you do this when you add new lines of code, you immediately press run or compile or like you press play on it. You just have this feeling like I need the reassurance of seeing it work again. Sometimes you make no changes and you hit play again. It's like the classic in a game where you shoot one bullet, better reload. So yeah, regression testing is important because it ensures that a change doesn't break some pieces of the code that have already been tested. It ensures that no new bugs are introduced as a result of implementing. It says a software update here, but it could be any software change at all. Okay, the part C here says explain what this little code does. We kind of already did that, I suppose. I said the secret here is do not start with if not. Start with the 0 there in the square brackets. So this means the first term. The first term of what? The first term of test error code. What are we doing with test error code? Well, we're saying is it an alphabet number? Okay, yeah. Now, so this says is the first thing a letter, yeah? And then it says, if not a letter, return false. That's what it does. So if whatever it's looking at is not a letter, it will return false, right? But if you don't read it from the middle out, you could end up with this kind of getting confused where you're like, wait, did they say not false or not false? You know, if you are getting confused with the not trues and the false, it may or may not be helpful to put in a test value and just in the margin work it out, like debug mini bit of Python. So in this case, if you put in a test error code here, which is, let's say 1, 2, 3, blah, blah, blah. So 1, for example, is it an alpha? It's not. Okay, so that's immediately going to give you a false. Not false is true. If true, return false. So that's going to return a false. So that would be like, okay, well, I know that from doing this, if I put in a number, it gives false. If I put in a letter, it gives true. So the marking scheme agrees here. It just says that the code checks if the first character passed, see what we're saying, passed through a function from earlier on, passed in is a letter or not. If it's not a letter, it'll be true and the function will return false. I've summarized with a little diagram here to say there's a box. You put in your error code. If the first character is letter, say true. If not, say false. That's kind of what it does there. Okay. Part 2 looks like there's a lot of writing in here, but this is so nice because it's like the easiest logic gate question ever. It just says P on the left here. Can you make not P? And when it's talking about P, I suppose you should know for later, it's the stuff in brackets here is P and the stuff in the brackets to the right is Q. You don't even need to know that. Honestly, like that text could just not be there and it could just be fill in this logic table and you could do it. So not P is just the opposite to P. So every false becomes true, every true becomes false because this is a not gate. It's like a little triangle and it's got a dot. The not for the dot for the not. It's like a pyramid upside down, like an inverted pyramid. And here's an example of it in a circuit. You can see down the bottom, this line along here is to be, and the stuff down the bottom is to not to be, because it's been knotted. And then there's an or, so to be or not to be, because jokes are funnier when you explain them. Not at all. Not P. Not P is very simply, let's you take P here, you go false becomes true. False becomes true. The next P, true becomes false, and true becomes false. And then not Q, you take that false, you invert it, that goes true, true becomes false, false becomes true, and true becomes false. Now that you've got that, we just OR these together, all right? What does OR mean? Well, if someone says, I'm going to give you like some Quality Street or peanuts, I'm sure you know what OR means. It's one or the other. Both is a bonus, but you definitely don't want none of those. That's what you're not expecting. And that's exactly what the logic looks like. So the only thing that will upset you here and you'll get a 0 points, is if your friend brings you none. They get 1 point if they get the right thing, 1 point if they get the left thing, and they get a point if they get either, if they bring both. So that's exactly what I'm going to do. I'm going to replace P and Q with peanuts and Quality Street, and we're just going to do this with the OR gate. So if I asked for peanuts or Quality Street, and you came to me with true, so both of them, yeah, that's fine. Truth. That's OR to me. If you only gave me peanuts and no Quality Street, yeah, grand. If you only gave me Quality Street and no peanuts, that's fine. If you gave me nothing, that is not fine. That is not what we agreed. So I will return false. You have failed in your mission. So that's the answer to that one. And there it is in a marking scheme. Let's just do the same thing using peanuts and Quality Street again, this time with an and. Okay, false. I asked for peanuts and Quality Street. You gave me nothing. That false. You failed your mission again. Peanuts. No. I wanted both of them. So that's false. True and false? No. I wanted both of them. They need to be both true. So that's also false. Oh, that color's wrong. And true and true. That's what I'm talking about. I want both of them. That's what and means to me. And then the not thing, what do? You just flip and turn it upside down. So false becomes true, false becomes true, false becomes true, and true becomes false. And that just got knotted. That went upside down. So there you go. There's the thing in the marking scheme. Part 4 was a bit of a tricky one. It's saying using your findings from part 2 and 3, rewrite this without changing its logical meaning. Okay. Yeah, well, the trick to doing this one was looking back on your previous answers and noticing that they're identical. Okay, so it's, if you can see that not P or not Q is the same as not P and Q. All right, and it's very similar to like if you have in algebra, if you have 4x plus 6x, you can go, oh, well, that's just x times 4 plus 6. In brackets, you're taking something out of the brackets. That would make sense, except this is Boolean algebra. So when you move something out of the brackets, that or became an and. Like, you wouldn't have known that. You see, I think you have to have gotten the previous ones right and look back at your answers. Now, given the last previous ones were pretty easy-ish logical gate questions, I think you'd be in a good chance. But yeah, I don't think you're expected to know full Boolean algebra at this level. So tricky one, that one. But what you had to write here is, you take the not outside the brackets and you put the and in the middle. Now you were allowed to just leave it as P and Q, which is nice, I suppose. But still, I don't know, that's a tricky one. So part 5 says, explain how string slicing could be used to provide, well, how to make this better with string slicing, because that is that's a nasty looking thing. It's looking at the second digit or the third digit not being a digit. But like, what if this was even worse? What if this was like some code where you had to do 10 of them? Like, that's a lot of ors. Or not. You're down to like, that's not good code. So because they appear right next to each other, you just be like those two. Or from 2 to 6 if it was a bigger thing. And you use string slicing to do that. So from this to that is a string slice. And here are like from 1 up to 3. Or from the last 3 down to the last 1. It's this kind of thing here, So that's how it could have worked. And this is what it could have said instead. And like that's a lot tidier. I mean, I would say probably was to write this code, I would have avoided the not entirely, and just instead of saying false or whatever, just said true, and then I wouldn't have had to do anything. So, but I suppose it's supposed to be a question on a Leaving Cert exam, so they're kind of, it makes sense to ask like that. But still, none of this was really required to begin with if you were just writing a program, but it was a journey in the end, I suppose. We've made friends along the way. So that is the end of that long question, which in part was easy, but there was 1 or 2 parts of it where I feel like, it was a little bit tricky. But there you go. Learn logic gates and validation and testing, and you'll be grand.